J. Robert Oppenheimer is famous for his work on the atomic bomb, but he also helped to predict the existence of black holes. Along with his student, Hartland Snyder, he developed what is now known as the Oppenheimer-Snyder model, which is about how a very dense star can collapse into a black hole. How does this tell us that we could be living inside a black hole? If you're familiar with the Big Bang theory, you will know that it is usually explained as the entire universe being produced by an explosion, by the Big Bang. However, two physicists, Joel Smoller and Blake Temple, realised that as any other explosion creates a shockwave, then the Big Bang should also produce one. And they spent 10 years combining shockwave physics with general relativity, with Einstein's theory of gravity. In 2003, they published a paper called Shockwave Cosmology Inside a Black Hole. They had come to think that our observable universe could be the result of an explosion inside a black hole. In their model, we are still currently inside that black hole as it expands into a larger existing space. At some point in the future, as the matter and space from that explosion continues to expand, its density will reduce to the point where it will no longer create an event horizon on its outside. To an observer on the outside, it would then no longer be a black hole and would suddenly appear as a white hole. The galaxies, stars and other matter would then continue expanding into that outside space. But doesn't a black hole crush everything inside? That's where the Oppenheimer-Snyder model comes in. They modelled the collapse of a star and showed that during the collapse, the inside would have flat space-time, while the outside would develop the black hole event horizon. If a black hole were to explode, this would happen in reverse, so we would have an expanding flat space-time inside a black hole event horizon. What do astrophysicists make of this idea? They don't see it as currently giving a better explanation of the universe than the Big Bang theory. But it does produce a universe that looks essentially identical to the aftermath of the Big Bang. Here's why I like this shockwave cosmology. If our visible universe is the result of an explosion of a black hole into a larger space, then that larger space could also contain many more such black hole explosions. And then, where the matter from these meets up, eventually hypermassive black holes would form, ones containing more mass than is in the entire observable universe. At a certain point, perhaps when they reach a critical mass, these hypermassive black holes could explode, creating the stars, galaxies and all the other features that we can see in the night sky. So this could explain the origins of the Big Bang and point to a likely future for the universe, with a constant sort of bubbling of exploding hypermassive black holes and new ones being formed. And so rather than a big freeze, which is a current prediction of the Big Bang model, we would have a universe that is consistent with the perfect cosmological principle. That is, one where the universe stays, in a sense, largely the same across space and over time. Interestingly, Smoller and Temple have also proposed that their model could explain why the expansion of the observable universe is accelerating without needing dark energy. In their model, the acceleration is caused by our part of the universe being less dense than its surroundings, and they also propose a test for this. I've written more about all this and included links to the scientific papers at WordPress Universe of Opposites.